Hi everyone, here we are a team of three who want to give a demo for the project we worked on as a part of Capstone. Our topic is conversion of unstructured text to knowledge graph. As the title implies, our motto is to build a knowledge graph from the unstructured text and to query the obtained graph to get useful insights. In order to reach our goal, we perform the following tasks which I'll be discussing in detail. We observed 4 milestones before starting the project. First was to select the dataset and to pre-process it. Then finding the entities and recognizing the relationship. Then comes knowledge graph construction and interfacing with the Google Knowledge Graph Search API. Here is the architecture which summarizes all the stages from data extraction to the graph creation and the result comparison. This is the phase 1 of our work. What is unstructured data? Any data which is not organized in a proper manner. This kind of data cannot be saved in the database. Hence, we need to organize it to find the entities and relationships. For this, we perform scraping and obtain the information about people who are associated with movies. As a part of pre-processing, we tokenize the text and try to remove all citations, punctuations and others. Then we try to resolve co-referencing. Let me explain what co-reference means. When two or more expressions in a text refer to the same person or thing. For example, Jacob is a singer and he is also an actor. He is resolved here as Jacob so that we can get exact entities for the later proceedings. The second phase of our project involved finding the entities. For this, we need to implement a CRF model and obtain the annotations. We produced the annotations which followed IOB scheme, that is, inside, outside and beginning of the entity. After that, we need to find the entity type. So, this type specifies if an entity is a person, organization, location or other. After we get the entities and types, we need to extract the relationship. For this, we need to perform dependency parsing. What is a dependency parser? A dependency parser analyzes the grammatical structure of a sentence, establishing the relationship between the head words and the words which modify those heads. So, this is then translated into subject-verb-object triples. As we can see to the left, Jacob is a singer, Jacob is an actor. By performing the above steps, we distinguish the entities by tagging them with the appropriate type and then we convert to SVO triples which give us the relationship. Before proceeding with the above implementation, we initially took JMB annotated corpus from Kaggle and performed accuracy test. As it gave 80% as a result, we annotated the unstructured text and followed the same NLP model for our dataset. Here comes the interesting part, the knowledge graph construction. We made entities as nodes and relationships as directed edges. For this visualization, we used Neo4j. To query the knowledge graph, we used Cypher. We can see our results from relationships to graphs to the queried results. To the left, we see the produced graph from the given dataset. Here is a big picture of the query which we performed on our data. We have implemented the following queries which is shown on the screen. Final step is to benchmark the results with the Google Knowledge Graph Search API. Google's API produces the results which are in the form JSON LD or RDF. The left screenshot portrays the results from our implementation which says that Jacob is a singer and actor. Similarly, we find the Google API producing the same result. We see the highlighted text from the right hand side of the screenshot. This is a folder which we share with you and we have a README file, code folder and dataset folder. README file gives all the instructions to the initial setup of the project. This file provides the implementation for web scraping using beautiful soup with which we collected the dataset. In this file, you can see the comparison between CRF and SPACY model. In ner_er file, we see the implementation where names and relations are obtained. Finally, this file shows the graph implementation and the querying stuff. As we can see, this is a menu-driven model. If you see here, we have queried for obtaining the names of the actors, producers, multi-talented people, specific person, and all the relations in the knowledge graph. Here comes the final step. We now compare the results of our query with the results produced by the Knowledge Graph Search API. That's how we finally converted unstructured text to knowledge graph, queried and compared with Google API. Thank you.